Here at BYU Geology, we love going on field trips. This field trip that you're going to see right here was a trip that we took in our geochemistry class to Yellowstone National Park so that we could learn more about different geochemical processes that happen inside the park.
We're at the Norris Geyser Basin. This is the hottest, most acidic, and most active geyser basin in Yellowstone. It is part of one of the world's largest, most active volcanoes.
Think about your project and what you want to be able to say.
Hidden just inside of this steam is Emerald Spring. And that's this beautiful clear blue pool of water that goes about 27 feet down, or roughly 8 meters. However, it's also mixed with sulfur, which reflects a yellow light. So that blue and yellow then combine to give this deep green look of the water, where its name comes from, the Emerald Spring.
This is the Steamboat Geyser. It's the world's tallest active geyser. It's kind of unpredictable, and the last major eruption was in April.
So this thermal camera is showing us the temperature of everything we see. The yellow, white areas are higher temperatures, and the red and purple areas are lower temperatures. So right where the geyser is coming out, it's around 50 degrees Celsius.
A lot of times when it erupts, it actually has the potential to ruin people's cars because it's so acidic that it affects the paint job and the windshield. Say be careful with where you park your car.
So as we look around the geyser, we see all these dead trees, and the easy thing to say is like, well, the geyser and the salts and the sulfur killed off the trees. But my question is, why did the trees grow in the first place if this geyser has been here for so long?
So right now we're at the Mammoth Hot Springs in Yellowstone, and these hot springs are really cool because unlike the other hot springs that we were looking at, these have a lot of carbonate material. So the water goes down into the ground and it goes through limestone and dolomite, and it collects a lot of the minerals in there. It's heated underground to about 100 degrees Celsius, and then it comes up through vents to these hot springs. And then the different carbonate material that's within that water precipitates on the land here at these different terraces and continues to build up these travertine terraces into what they are now. So you see a lot of different carbonate materials and precipitates here. And the surface of these hot springs is about 70 degrees Celsius.
As we look out across the Mammoth terraces here, you might notice there's many different places where there's either like build-up ripples, or you can tell that things have had carbonates form over them, and these are just called shrubs. And the shrubs here are just naturally building up over either, it can sometimes start on top of something, other times they can just form and then build up on themselves here. The amount of water that Old Faithful gives off in a single eruption can be equated to 3 weeks worth of water used by a family of 4. So that family of 4, all of their 3 weeks, showering, washing food, hands, the lawn, all the lawn care, all of that, give it all in about a minute right here. Old Faithful has more recorded eruptions than any other geyser in the world, with over 1 million accounts and counting. Its consistency can be contributed to the fact that its thermal network, where the water boils up from the ground, is not connected to any of the other geysers or thermal activity around here, making it extremely reliable. Over the decades, 3 major earthquakes have caused the reliability of Old Faithful to be slightly lengthened, and the reliability of the accuracy of times to be lengthened from around give or take 5 minutes to now give or take 20 minutes. Early settlers in the area actually used Old Faithful to do their laundry, finding that it cleans their cotton and linen clothing almost perfectly. However, interestingly enough, it completely destroyed any wool clothing that they tried to put in it. Now today, obviously no one is allowed to put any of their laundry or anything else in the geysers, as the tubes that have the water come up and show us these beautiful landscapes and features can be easily clogged and permanently ruined by putting stuff into them, which is why it's important today that we preserve what we have. So my question for you guys is, Why did it destroy the wool clothing? Because I legitimately don't know.
But we are at the Grand Prismatic brand because it is the biggest in the US, and prismatic because there are a lot of colors that maybe you can slightly see reflecting.
The colors are created by thermophilic bacteria, meaning they love hot water. And the yellow and colorless bacteria love the hottest water. Those are the hottest temperatures. And then the green, brown, and orange bacteria are lower temperatures but still really hot.
So what we're looking at right here is the fountain paint pots. Unlike fumaroles and hot springs and geysers, this is not sourced, the fluid in here isn't sourced from groundwater. What we have right here is H2S steam coming up from underground. The heat's coming from underground, and that acidic steam is, and then it interacts with surface water, and that creates an acidic sort of solution as well. And so when that happens, it starts to break down all of the soils around it and forming those secondary minerals. So we get all these clays forming, and it mixes in with the water, and that's how you get that muddy sort of texture in there that looks like paint. And it's really hot, so it's bubbling, and it's probably one of the coolest things to look at here in Yellowstone National Park.
This is Red Spouter. It was formed in 1959 by an earthquake. It's younger than Scott Ritter is.
There sure are a whole lot of really cool sights to see, and we're really grateful to BYU Geology for making it possible for us to get out there and see everything around us.